I have put in everything that's been given to me in the question, and then I simply have to do 4 calculations here, right? So we have to figure out which formula we need. So 4 calculations there. I have to add up all 6 totals, and then I have to divide 1 by the total resistance. Okay, that's the extent of the amount of calculations in this one. The number of layers may differ from question to question, all right, but they don't go above 7 or 8 anyway. Okay, so now we want to look at what formula we need to use. Okay, so we have 2. So we have R is equal to R by T. Resistivity, thickness. Do I have the 2 of those? I do in this case here. So I have resistivity, I have thickness. The other one then is resistance is equal to thickness divided by conductivity. I was given no conductivity figures, so I'm just going to put a line through that formula there. I don't need that one in this case. Okay, so I have 4 multiplication questions here basically. Okay, so I'm going to go with the first one first, obviously. So 1.250 multiplied by 0.024 gives me 0.03. Alright, so then we're going to look at the next one then, same thing, multiplication, so 0.710 multiplied by 0.070, which gives me 0.0497. Alright, and we'll carry on. So we have 0.690 multiplied by 0.190, which gives me 0.1311. And then the last one then is 2.170 multiplied by 0.015, which gives me 0.03255. Okay, so that's my multiplication done. Okay, the next thing then, we're only at 11 minutes so far, and that's talking through fairly laboratory. Alright, so we're going to add up all these. Okay, so I'm going to go 0.413 plus 0.03 plus 0.0497 plus 0.1311 plus 0.03255 plus 0.104, which gives me a total resistance of 0.76. Okay, if we're to go another step further, we go 0.4. Okay, just to be clear. All right, so now that's our total resistance there. All right, so then we need to find the U value. Okay, so our U value then, so U value equals 1 over total resistance. And your unit is watt per meter squared Kelvin. Okay, so the unit of power, the surface area we're doing is meter squared, so it's 1 meter squared, right? That's why you have to have our thickness in meters, and then K is Kelvin, so it's your unit of temperature. Okay, so then for our question here, our U value is equal to 1 divided by 0.7604. Okay, so that's what I'm going to put into the calculator. So 1 divided by 0.7604 gives me 1.315. Alright, so that's 1.315 watts per meter square K. Alright, so to get to that point, we're at 13 minutes. Okay, so just going to do a bit of explanation then on where your marks are coming from on that question then as well. Okay, so if I can find my marker now, it'd be handy. Okay, so each Each row calculations is worth 3 marks. Okay, so to put that one in there, so that was 3 marks there. Okay, even just to write that in, even though it's not a calculation, it's still a layer in the table. So that was 3 marks. So that was 3 marks here. 3, 3, 3, and 3. So that's 18 marks there, right? So top and the bottom one, you literally just had to put in the figure. That's where you got 6 marks for doing that. Okay, so then you got another 3 marks then for your total resistance. Okay, so there's your 3 marks there, and then you got another 3 down here for doing your U value. All right, so in this case, that's how this question is marked. Okay, so you have 3 for each layer in the table, then 3 for your total resistance, and then 3 for your U value. All right, and that in this case, in this question, if you got that part there, you got 40% of your question. You know, so that's just something to try and target. Okay, so that's part A of pretty much all U value questions. So the things to remember: start off by writing down your 2 formulas first. Right, that's where I would start off first each time. Then you start off by drawing your table. Make sure you put in your symbols just to remind yourself when you go to do your formulas which one is which. So conductivity K, resistivity small r, thickness T, but make sure you write it in meters. Right, you would have seen me calculate it there on the calculator for those of you that find it difficult. Alright, so and then some of you will just be able to convert them, but just make sure you're converting them correctly. And then you have your resistance then, which I should have had as big R there. Alright, I've had to put it in from the beginning. Okay, so that's part 1 of the question.